Hello everyone. Today we will be presenting our group project that we did on temporal and category based CPI price similarity network analysis. I am Ifat Fatma here with my two partners, Ayman Asim and Maidan Naveed. Our goal basically was to analyze the economic similarity between major Pakistani cities in Pakistan by examining their consumer price index trends from 2023 to 2025. By using monthly CPI data from the Pakistan Bureau of Statistics, we grouped the items into seven major categories and then we constructed similarity networks to identify influential cities and clusters. In today's video, we will walk you through our methodology, our six coding phases, our code outputs, visualization, and finally we will interpret our results and conclusion. Now, Ayman Asim will describe the methodology and mathematical modeling.
Assalamu alaikum. I will now explain the methodology and mathematical modeling. First, we started by selecting monthly CPI data as Ifat just explained for 25 major cities, which you can also see over here. And for seven categories like food, staples, and grains, condiments and sweeteners, fruits and vegetables, and more. Missing values were handled using imputation, and data was normalized using z score and min max scaling. This ensures fair comparison across all cities. So, categories with large numeric values do not dominate the similarity computation. Next, we computed the cosine similarity between city pairs for each category and year using this formula, as you can see over here. Uh, this produced a similarity matrix for each category and year, which we then use to construct the networks. We also did temporal relations, and this relation thus showed us that this is reflexive, antisymmetric, and transitive, and also showed us to how to visualize how these networks evolve from one year to the next. Next, Maida will explain the phase one and phase two codes.
Hello. So for this project, we have a total of six phases. For phase one handles data loading and pre-processing. Here we read CPI CSV files from Pakistan Bureau Statistics website, mapped cities to categories and handled missing values. The code snippet here shows how missing values are replaced with the category mean per city. Next, we normalize the data using both z-score and min-max scaling. This ensures that each category contributes equally to the similarity calculation. Now for phase 1 output, we have a cleaned CPI table that has no missing values, which means our similarity calculations later will not be distorted. Z-score results help us compare changes across cities even if their CPI levels are very different. Min-max results allow easy visualization and plotting. The processed data shows smooth, consistent values, confirming that the data set is ready for modeling in phase 2. Now, for phase 2, we have it computes the cosine similarity matrices for each city pair. The code calculates similarity per category and stores the matrices for each year. Now, for the interpretation of phase 2 output, we have the correlation heat map, the weighted graph, and the threshold graph. For the heat map, open the heat map. For the correlation heat map shows clusters of cities whose CPI trends move together, for example, Lahore, Rawalpindi, Karachi, and Hyderabad, for different cities and different categories. Okay, for the weighted graph, the weighted graph keeps detailed strength information, which we later used for weighted centralities. The threshold graph simplifies the structure, enabling us to measure graph density, connected components, central nodes, and path lengths. The network becomes visibly structured. Highly correlated cities form a community while weaker links disappear. So now, if it will do the code demonstration for phase 3 and 4.
Okay, So what happens in phase 3 is we take the similarity scores that we did in phase 2 and we convert them into actual graphs. So how do we do that? We have two major tasks here. First of all, we make the threshold graphs. So for that we have the condition that the edge will be created that if our similarity passes or is equal to the threshold, and it means that if two cities have similarity above this threshold, that they will become connected, and if they don't, that means that they won't have an edge. When it comes to the output, we made it terminal based so that the user could ask themselves. We also did the weighted graph construction in phase 3, meaning that the full similarity value is used as an edge weight, so every pair gets an edge unless it is diagonal, and if there's strong similarity then there's high weight, and if weak similarity then low weight. So as you can see here, I will select any category, 5, and then select a year, and then I can open the images. We have hash diagrams, the weighted and the unweighted network graphs. Okay, this is hash diagram, and then this is unweighted and this is weighted. Now we move on to the phase 4. Wait. Okay, basically, what we are going to do here is we're going to focus on calculating the four centrality measures, which will help us identify the most influential cities by the four categories, which is degree centrality, closeless centrality, betweenness centrality, and eigenvector centrality. So, for each one, we did the calculation, and then we made CSV files that, as you can see, wait, let me show. These are formed and they contain all of the centralities, as you can see. So this is basically what we did in phase 4. Now Eamon will explain phase 5 and phase 6. Basically in our phase we validated our earlier clustering result and confirmed that the economic structure of the dataset will revolve around small number of central cities.
Okay, so now I will explain phase 5, which focuses on generating all the required visualization for our project. Can you open it, please?
Yes. Should I run?
Yeah. So, uh, phase 5 applies entropy-based weighting to the centrality measures. This reduces bias from metrics with low variability. The steps are, first we normalize centrality metrics. We then compute entropy and diversity for each of these metrics. We then calculate weights proportional to this diversity, and then we aggregate metrics to produce a final city influence score. The ranking, as you can also see, remains stable. Betweenness and the betweenness and eigenvector centrality slightly increases uh, in importance, but the top five cities are unchanged, showing robustness. Can you show the cities, please? Okay, next in our phase 6, we generated some visualizations. For example, we produced heat maps of similarity matrices per category and per year. We then also produced some threshold network graphs showing sparse versus dense connections. Also, we produced degree centrality comparisons for raw versus weighted similarities, and then also temporal hash diagrams illustrating network evolution from 2023 to 2025. Can you please show the this is the graph density versus the temporal relations. This is the top 5 similarity graph, the heat map. Next is the weighted versus threshold graph, which I also included in the report, and also hash diagrams were also produced. This also confirms that similarity edges expand over time, indicating more consistent CPI behavior across major cities. Next, Maida will tell us about the interpretation of all this.
As we've already shown you different types of graphs, for example, graph density versus threshold, heat maps, weighted graphs, unweighted graphs, weighted versus threshold graphs. So now for the interpretation, we have across all thresholds, normalization methods, and weighting schemes, the top influential cities remain consistent. And these are Islamabad, Rawalpindi, Multan, Gujranwala, Lahore, and Faisalabad. So now for different types of graph density versus threshold. For its interpretation, we have that as threshold increases, network density decreases, but core city clusters remain intact. For heat maps show strong similarity patterns between top ranked cities. Weighted versus threshold graphs. Weighted graphs capture subtle differences, while thresholded graphs highlight the strongest relationships. This confirms the structural and temporal robustness of the CPI similarity network. The results validate our hypothesis that intercity price trends are stable and predictable. Now, for the conclusion, we successfully constructed temporal CPI similarity networks for Pakistani cities and analyzed them through graph theory. Top influential cities were consistent across all modeling choices. Future work can include more granular product level data, incorporate inflation shocks, or use dynamic temporal graphs for deeper insights. Thank you for watching our presentation.